Okay. Problem statement. A beam of length 8 meter is simply supported at its end. Carries a uniformly distributed load of 40 kilonewton per meter as shown in figure. Determine the deflection of the beam at its midpoint. Full stop. Take E as a 200 GPa and I it is 4.3 into 10 raised to the power 8 mm raised to 4. Okay. So first of all, calculate the reaction of this beam. First step to calculate reaction of this beam. To calculate reactions of the beam. Reactions of the beam. Okay. So reaction at the beam. So we need to calculate reaction at A, that is RA, and reaction at B, it will be RB. Okay. So first of all, calculate the reaction due to this UDL load. UDL load, it is acted C2D, it is 40 kilonewton per meter. C2D distance, it is 4 meter. Okay. So first of all, apply the equilibrium equation. Summation of MA is equal to 0. Algebraic sum of all the moment at A is equal to 0. MA is equal to 0. Okay. So for that movement, we need to some assumption. If the movement it is clockwise direction, it will be take positive. The moment it is clockwise direction, it will be take positive. If the moment it is anti-clockwise direction, it will be take negative. It will be take negative. Okay. So first of all, this 40 kilonewton per meter, convert it is in point load. So 40 into 4, it will be 160 kilonewton. It is acted center of CD. That is means 160 kilonewton. 40 into 4, it is 160 kilonewton. It is acted center of CD, means it will be C to this center, it will be 2 meter. Okay, so the distance it is 2 meter from C. Okay, and from D it is also 2 meter. So total distance it is 2 plus 1, it will be 3 up to A. So take moment at A. So when moment it is clockwise, it will be take positive. So 160 into the moment at A, 160 into perpendicular distance, it is 2 plus 1. It will be 3 meter. It is rotating clockwise direction. So that's why I have taken positive. Second, minus RB. RB it is rotating about the, it will be anti-clockwise direction. So RB into perpendicular distance, it is 3 plus 4 plus 1. 3 plus 4, it is 7. 7 plus 1, it is 8. 8 is equal to 0. So from this relation, it will be get RB. Reaction at P, it will be 160 into 3 divided by 8. So it will be 60 kilonewton. 60 kilonewton. So RB it is 60 kilonewton. So now apply second equilibrium equation. Summation Fy is equal to 0. Algebraic sum of all the vertical forces is equal to 0. Summation Fy is equal to 0. Okay. So for that, one force it is going upward direction, it will be take positive. If the force it is going upward direction, this one it will be take positive. If force it is going downward direction, it will be take negative. Okay. Force it is downward direction, this one it will be take negative. Negative. Okay. So RA it is going upward direction, RA. Then minus 160 it is going downward direction, 160. Then plus RB it is upward direction, it is plus. So RB we are calculating it is 60 kilonewton is equal to 0. So it will get RA is equal to, from this relation, RA is equal to minus 160 plus 60. So it will be minus 100. So it will be take right side. So it will be get positive value. So it means it is 100 kilonewton. Okay. So RA it is 100 kilonewton. RA it is 100 kilonewton. And RB it is 60 kilonewton. RB it is 60 kilonewton. RB it is 60 kilonewton. Okay. So next, Young's modulus it is given. E is equal to 200 GPa. 200 GPa. Convert it is in Newton per mm square. That is 200 into 10 raised to the power 3 Newton per mm square. Newton per mm square. Okay. So this one it is Newton per mm square. E. Then moment of inertia I is equal to it is I is equal to, so this one it is 4.3 into 10 raised to the power 8 mm raised to 4 mm raised to 4. Okay. So this one it is moment of inertia mm raised to 4. Okay. So EI is equal to calculate EI. So 200 into 10 raised to the power 3 into I, it is 4.3 into 10 raised to the power 8. 10 raised to the power 8. 10 raised to the power 8. Okay. So EI is equal to 200 into 10 raised to the power 3 into 4.3 into 10 raised to the power 8. So it will be 8.6. 8.6 into 10 raised to the power 10 raised to the power 13 Newton mm square. Newton mm square. Newton mm square. Convert it is in kilonewton per meter square. Okay. Convert it is in kilonewton per meter square. Okay. So EI is equal to so we need it is in kilonewton per meter square. So 8.6 into 10 raised to the power 13. So this one it is Newton per mm square. So we need to convert it is in kilonewton per meter square. So first of all, Newton per mm square, we need kilonewton. So means divided by 1000. Mm square to meter square, it will be need 1000 square. Okay, 1000 square. It will get mm square to meter square. Okay, it will get kilonewton per meter square. Okay, divided by 8.6 into 10 raised to 13 divided by 1000 into 1000 square. It will get 86 into 10 raised to power 3. 86 into 10 raised to the power 3 kilonewton meter square. Kilonewton meter square. Okay, converted this one Newton mm square to kilonewton meter square. I will note down this one. It is 86 into 10 raised to power 3 kilonewton meter square. Okay. The next step, once calculate the reaction of this beam. Okay. The reaction of beam, it is RB, it is 160 kilonewton. RB is 60 kilonewton. 60 kilonewton. Okay. Now second step after calculating the reaction, necessary to extend UDL D to B. UDL D to B. Okay, so we need to necessary to extend UDL D to B. Okay, necessary to extend UDL D to B. Okay, so we just extend this UDL D to B. Same quantity, it is 40 kilonewton per meter. Okay, 40 kilonewton meter. We'll just extend this UDL 40 kilonewton per meter. Same quantity, it is 40 kilonewton per meter. Okay, so just apply same quantity of UDL on D to B upward direction. Okay, if you done summation Fy, it will get same value. Okay, then second step, third step, apply upward UDL from D to B, from D to B, from D to B. Quantity will be same. That is 40 kilonewton per meter. Quantity will be same, that is 40 kilonewton per meter. 40 kilonewton meter. Okay. So now for consider section XX at a distance X, at a distance x from A, x from support A. Okay, so just we will need to consider section XX. So this one it is section XX, section XX, section XX at the distance x from support A, the distance x from support A. Okay, so moment at XX, moment at XX, so moment at XX, so mxx is equal to, write down. So first of all, this take UDL. Okay. First of all, we need to take this UDL part. So this one it is x distance. Okay, so how much this distance? So this distance it is total, it is x minus 1. E2, this x distance it will be, this distance it will be x minus 1. Okay, so moment at xx. So first of all, 100 into x. So how it is rotating? It is clockwise direction. Take clockwise positive. 100 into x, then minus 40 into 40 into. So first of all, convert it is in point load. That is in bracket x minus 1, x minus 1, x minus 1. Then again, it will be center of x minus 1 by 2. So it will be x minus 1 square divided by 2. X minus 1 square divided by 2. Then upward UDL plus this distance it will be. So now this distance. Okay. So how much this distance? Yes, this distance it will be x minus 5. This distance x minus 5. X minus 5. So again, then plus 40 into, in bracket, first of all convert it is in point load, means divide multiply by x minus 5. Then it is acted center of this x minus 5 by 2. So it will get x minus 5 bracket square divided by 2 divided by 2 divided by 2. Okay, here once again I will explain this one, how you will get 40 into 40 UDL, this one 40 into x minus 5. So it is acted center of this span, upward direct. This one acted center of this span. So 40 into x minus 5. So this distance it will be x minus 5 divided by 2. Okay, x minus 5 divided by 2. So x minus 5 into x minus 5 by 2, it will be get x minus 5 by square divided by 2. Okay, similarly this one also. Okay, so 40 into x minus 1. So it is acted center of this x minus 1. So means this distance it will be, how much this distance? It will be this distance x minus 1 divided by 2. So x minus 1 into x minus 1 divided by 2, it will be get x minus 1 bracket square divided by 2. Okay, so this one it is moment at xx, moment at xx. Okay, so now Maclaurin's method says that ai d2y 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 divided by dx square divided by dx square divided by dx square is equal to m, is equal to m. Okay, so that is mxx. So moment at xx. So here all this value. So ei d2y by dx square d2y 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 divided by dx square divided by dx square dx square dx square is equal to 100x minus 40 into, in bracket, x minus 1 square, x minus 1 square divided by 2 divided by 2, then plus 40 into x minus 5, 40 in bracket x minus 5 square, x minus 5 square divided by 2, x minus 5 square divided by 2 divided by 2 divided by 2. Okay, so this one integrate with respect to x this equation. So write down integrate with respect to x, integrate with respect to x. So you can say it will be equation 1. You can write down this one, it is equation 1. Equation 1 we need to integrate with respect to x. So it will get ei. So integration of d2y by dx, it will be dy by dx, dy by dx, dy by dx, dy by dx is equal to so 100x, it will be integration of 100x, it will be x square by 2, x square divided by 2, x square divided by 2, x integration of x, it will be x square divided by 2, then minus 40 integration of x minus 1 bracket square, it will be x minus 1 bracket cube divided by 3, 3 to the 6, x minus 1 bracket cube divided by 3, so 3 into 2 it will be 6, then plus 40 in bracket integration of x minus 5 square, integration of x minus 5 square, it will be x minus 5 cube divided by 3, 3 to the 6, 3 to the 6, then plus c1, just simplify this equation, it will get ei write down it, ei dy by dx is equal to so this one it is 2 1 the 2, so this one it is 50 to the 100, okay. So 50 square, 50x square, then 2 3 is the 6, 20 to the 40, then minus 20 in bracket x minus 1 cube, divided by 3, x minus 1 cube divided by 3, 3, 3, then plus again plus 40 in bracket x minus 5 cube, so you can say it will be plus again here 2 3 is the 6, 20 to the 40, 20 by 3, then plus 20 in bracket x minus 5 cube, divided by 3, x minus 5 cube divided by 3 plus c1, 3 plus C1 plus C1. Write down this one, it is equation number 2. Equation number 2. Equation number 2. So now again integrate with respect to x. Again integrate with respect to x. Equation number 2. Equation number 2. Okay. Equation number 2. Equation number 2. Equation number 2. Okay. It will be get ei dy by dx, it will be y is equal to 50x square, it will be 50 into x cube by 3. 50 into x cube divided by integration of x square, it will be x cube divided by 3. X cube divided by 3. Then minus 20. X minus 1 cube integration, it will be in bracket x minus 1 raised to 4 divided by 4. 4 3 is 12. X raised to 4, x minus 1 raised to 4 divided by 4 3 is 12. Then plus in bracket 20 bracket x minus 5 raised to 4 divided by 4 3 is 12. Again we have 12 plus integration of constant c1, it will be c1x plus now c2. Okay, so write down this one, it is equation number 3. Equation number 3. Okay, this one it is equation number 3. So now apply boundary condition. Apply boundary condition. Apply boundary condition. Apply boundary condition. The boundary condition. When x is equal to 0, when x is equal to 0, comma y is equal to 0. Y is equal to 0. Put in equation 2. Put in equation 2. Okay. Put in equation 2. Okay. Put in equation number 2. So from this value it will be get C1, C2 value. Okay. Put in equation number 2. When x is equal to 0, y it will be get 0. So put in equation number 3. This, sorry. Put in equation number 3. Put in equation number 3. Okay, here. So this one it is equation number 3. So when x is equal to deflection, it will be here. Due to external loading, the beam will be deflect in that way. Okay, just like, okay, see here. So deflection at A and B, it will be 0 always. Keep in mind, deflection at A and B, it will be 0. So when x is equal to 0, so y is equal to also 0. So put this in equation number 3. So EI, y it is 0. So this one it will get 0. 50 into x cube divided by 3, this term it will be also 0. So minus 20 into x minus 1, 0 minus 1. So this term it will be take 0. Then plus again x minus 5 raised to 4. So 0 minus 5 raised to 4, this term it will be also take 0. Then plus c1 it is also take 0. Then plus c2. So c2 is equal to, it will get 0. C2 is equal to, it will get 0. Okay, C2 is equal to 0. So apply second boundary condition. Apply second boundary condition. Apply second boundary condition. Apply second boundary condition. Apply second boundary condition here. Okay, so I will note down C2 is equal to, here I will write down C2 is equal to 0. Okay, so second boundary condition now. Apply second boundary condition. Apply second boundary condition, second boundary condition, boundary condition, second boundary condition, condition when x is equal to, when x is equal to 8 meter, then y is equal to 0, y is equal to 0. Put in equation 3, put in equation 3, put in equation 3, and C2 we are already calculate, C2 it will be 0. Okay, so when x is equal to 0, so y it will be 0. So 0 I y it will be get 0 is equal to 50 into x cube, 50 into, so x cube it will be, x is equal to 8, 8 cube divided by 3, 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 then plus minus 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 20, x minus 1, x it is 8, 8 minus 1 it will be 7 raised to 4, 7 raised to 4, 7 raised to 4, 7 raised to 4 divided by 12, divided by 12, divided by 12, then plus 20, 20, x minus 5, 8 minus 5 it will be 3 raised to 4, 3 raised to 4, 3 raised to 4 divided by 12, divided by 12, divided by 12, plus c1, plus c1, x it will be 8 and c2 it will be 0. From this relation it will be get c2 value, okay, sorry, c1 value. So 8 raised to 3 divided by 3 into 50, okay, so this one 8533.33, then minus 7 raised to 4, 7 raised to 4 divided by 12 into 20, so minus 4001.67, then plus plus 3 raised to 4 divided by 12 into 20, 135, 135, then plus c1 into 8, c1 into 8, c1 into 8. From this relation it will get c1 value, c1 is equal to, write down, so 8533.33 minus 4001.67 plus 135 divided by 8, so it will be minus 583.33, 583.33 c1 value, okay, c1 value. So put c1 c2 value in equation 2 and 3, okay, so put c1 and c2 value, only put in equation number 3, because we need only deflection equation. So question it is to determine the deflection of the beam at midpoint, okay, so we need to only put c1 c2 values in equation 3, in equation 3. Why only in equation 3? Because we need to calculate deflection only, okay, so that's why we need to write the deflection equation, okay, so just I will write down the deflection equation, okay, so c1 minus 23.88, okay, so write down, okay, deflection equation EIY is equal to, so that is equation number 3, 50 into x cube by 3, 50 into x cube divided by 3, 50 into x cube divided by 3, 50 into x cube divided by 20 into x cube divided by 3, then minus 20 in bracket x minus 1 raised to 4, x minus 1 raised to 4 divided by 12 divided by 12 divided by 12, then plus 20 x minus 5, like x minus 5 raised to 4 divided by 12 divided by 12 divided by 12, then plus c1, it will be c1 value, it is minus 583 minus 583.33 x. Okay, so this one it is deflection equation. Okay, this one it is deflection equation. So this one it is deflection equation. This one it is deflection equation. Okay, so question 1 it is to determine the deflection at midpoint. Question it is deflection at midpoint. Okay, deflection at midpoint means total span it is 8 meter, means at 4 meter. So x is equal to put x is equal to 4 meter, and y is equal to, you can say it will be midpoint, ym. Okay, that is mid. Put in deflection equation. Put x in deflection equation. In deflection equation. Okay, so ei yc is equal to, so x is equal to 40, that is 50 into 4 cube divided by 3, 4 cube divided by 3, 4 cube divided by 3, then minus 20 x minus 1 means 4 minus 1, it will be 3 raised to 4 divided by 12 divided by 12, then 20 x minus 1. So 4 minus 1, this term it will get negative value. So we don't include this term. Okay, if we get negative, then minus 583.33 x, it is 4. Okay, from this relation ei yc is equal to, so 4 raised to 3 divided by 3 into 50, so 9600, then minus 4 raised to 3 divided by, sorry, 50 into 4 raised to 3, 3 raised to 4 divided by 12 into 20, 135, then minus 583.33 into 4, it will be 233.32. Now write down yc is equal to 9600 minus 135 minus 233.32. So this one it is 9600 9600 minus 135 minus 233.33. That will be 50 into 4 cap 3, 4 cap 3 divided by 3. Sorry, this one it is 10660. 4 raised to 3 divided by 3 into 50. So this one is 10600. 1066. This value 1066. 1066. So 583.33 into 4. So this one it is 233. And this one it is 3 raised to 4 divided by 12 into 20. 135. Okay. So YC it will be 1066.67 minus 135 minus 233.32. It will be minus 1401.65 divided by EI. It is where calculated EI value in kilonewton meter square. It will be 86 into 10 to the power 3. 86 into 10 to the power 3. Okay, so from this relation it will be 5C divided by 86 into 10 to the power 3. It will be minus 0.016298 meter. Convert it is in mm. So YC is equal to deflection at midpoint. YM midpoint it will be actually, okay. So into 1000. So minus 16.298 mm. Okay. So minus indicate the deflection it is in downward direction. So this one it is YM. Okay. YM movement at center. Okay. Midpoint. We can say it will be midpoint. So movement at center it will be minus 16.298. Minus Y it is deflection it is going downward direction. Okay. So this one it is deflection at downward direction it will be minus 16.298 mm.